very powerful tool in non-parametric test. So basically, to understand the concept first, let's jump into an example. First, if you can see here, there's a doctor who are just giving treatments to our patients. Now that is not our problem. The problem is the doctor had two treatments, say drug 1 and drug 2, and he wants to find out which treatment is better, which treatment outperforms against the other. For that very reason, and that is our problem, and for solving this problem in statistical analysis, we have this incredible tool, Mann-Whitney U Test. And the problem is there any significant difference between the two treatment groups? Here basically two treatment groups are basically two groups of patients. To verify which treatment is better, the doctor creates two groups, and separately he provide treatment A to group A, treatment B to group B of patients. Here is an important note. What is the significant? In statistical analysis, it's the most important part, significant difference. So we have to clarify that. If it is a difference, it's okay, but whenever you jump into statistical analysis, it needs to be a significant difference. Otherwise, it is not valid. So first important job that the doctor has been done through this journey, he provide treatments and he find these scores. And if you look at these scores, you can easily understand which treatment is outperforms against the other. If you look at this treatment group B, you will see high scores. That means the treatment B outperforms against treatment A. So it is very easy. Now we can say that treatment B is better. Why we need any kind of test like Mann-Whitney U test? Why we will go there? Because I already mentioned about you that there is an important factor in previous section. Is there any significant difference? Basically, for find out this significant difference, we have to move on the Mann-Whitney U test. So first of all, when you have this kind of a data set, a very small data set, which method you wanted to go for to find out the best treatment group? There's a lot of tests available in the world of statistics, parametric test and non-parametric test. So for find out this, which method that I will use, is it parametric or non-parametric, we have to understand and we have to observe this data set. First information in this data set, if you look at very clearly, we have 1, 2, 3, 4, 5, 6, only 6 observations. So we can easily say that this data set is small sample size. So our sample size is very small here. You can say that sample, otherwise you can say that the data set is small here. The next observation, if you look at in the treatment B group, there is a 20, and this 20 is higher score than other observation in between A and B whole groups. So this 20 is an outlier. So we have an outlier. First we have a small sample size, then we have outliers, and the next one, and one of the major important part, is that if you have this kind of a data set, the data will never follow any specific distribution. So if it is not follow any specific distribution, then we definitely not apply any parametric method. So we definitely have to go for non-parametric method. And now there is a lot of non-parametric methods available. Some are, you can say that median test. You can say about Mann-Whitney U test, Wilcoxon rank sum test. A lot of tests available in the world of non-parametric test. So which one we will use for that? It's totally dependent. Basically for this data set, you can apply two non-parametric tests. One is median test another one is Mann-Whitney U test. Now which one you will choose, it's totally depends on you. If you compare the median of these two between two groups, you can use median test. If you want to allow something more general, then you can go for Mann-Whitney U test. Basically, at the end result, both hypothesis rejection will be the same. That means the output these two methods will give you are the same. So it is not so necessary to specifically find out which test, because both of the tests will done this kind of a job to find out which treatment is better. But in more general way, you will go for here for Mann-Whitney U test, because the question that asked here is that is there any significant difference between two groups. So it's more general to use Mann-Whitney U test. If you want to use median test, you can also do that, no problem at all. But in general case, I will use Mann-Whitney U test. Okay, so we found which test in non-parametric that I will use here. It is Mann-Whitney U test in particular for this case. So okay, we have done our job. We found our test. Now we will apply the test. First one, you have to look at this formula. This is the main formula to find out the U calculated value. Here rank sum. You can see that basically in this data set you have to rank each observations. You have to rank these observations. Okay, and the rank is not general rank. See, here you have to apply combined rankings. That means you will not separately rank for group A and then group B. You will combine rank at a time, at the same time, two of these two groups. I made a video on practically applying this test by hand, so you can watch that video, so it will be more easier for you to understand. And the next one is, if you see here we will find two U calculated values, one for the group A, another for group B, and we will select the minimum of the two values between A and B group. So the minimum is 2 basically, so it will be our U statistics value, and the final one is our calculated value to find out. You will use a Mann-Whitney U test table, and based on that table you will find this result, which is here for 5 and for a specific level of significance. Now our U calculated value and U tabulated value are ready. Now we will go for the condition of this rejection of the hypothesis, and the decision is yes, the U calculated value is less than or equal to U tabulated value, in particularly for this case, so we definitely reject the null hypothesis. Okay, so what was our null hypothesis? Basically, in null hypothesis always states that there is no significant difference, but as now we are rejecting the null hypothesis, yes, there is significant difference between groups. And if you notice from the very beginning, from individually observing at a glance this, we very first we say that yes, there is a significant there is a difference. First we can by eye we can say that yes, there is a difference between two groups. Now after applying this Mann-Whitney U test, what we can say that there is a significant difference between two groups. Now it is statistically valid. You can report it as a research purpose. So next, in conclusion, what this test will benefits us, the doctor recommendation. Now doctor can recommend which treatment is better for the patients. Very easy. Next one, no guesswork. As a general public, you can guess and say that which one is better, but as a researcher, you cannot depend on this guesswork. It is not basically in the world of medicine or any kind of world of medical science, guesswork is a very dangerous thing. Okay, there could be life risks of some individuals, so guesswork is a very dangerous. So now the doctor no needs to guesswork. He can uh, uh, he can definitely provide the right treatment to the patient. Next one is credibility. So now the doctor has also the credibility. If someone claimed that the doctor gives him the wrong medicine, it will not possible right now. The doctors now have the credibility to provide the best treatment to the patients. So thank you for this part of the Mann-Whitney U test. And I think I have made a lot of videos over this Mann-Whitney U test. You can go over there and watch the playlist. I think that will help you a lot for understanding this Mann-Whitney U test. Thank you very much.